A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass on December 17th to Earth. Comet, asteroid, or something else? The Harvard astrophysicist believes there's a strong likelihood this is a craft of alien origin, and the implications, obviously, for humanity would be profound. A new visitor has swept through our solar system, one that is rewriting the rules of cosmic behavior and sending ripples through astrophysics. An interstellar object is known as the 3E Atlas comet, hurtling through at breathtaking speed and manifesting strange behaviors. Among them, what appears to be a bending of the solar wind around it. Comets have been around for a long time, but this one carries a sense of the alien, of something born beyond our sun's domain and behaving in ways that challenge conventional wisdom among scientists. It's caused by the solar wind's bending, that never-ending flow of charged particles emanating from our sun that now demands attention. At the moment, the scientific community is puzzling over what exact mechanism is at work, why this object is interacting with the heliosphere in unexpected ways, and what the broader implications might be. Before we start, smash the like and subscribe buttons for more updates. 3I Atlas was first detected in early July 2025 by the Asteroid Terrestrial Impact Last Alert System. Atlas is moving faster than any other interstellar visitor that has been seen before in Chile. Its trajectory is unmistakably hyperbolic, an indication that the Sun is not the original home of this object and that it will not bind to our planetary system. However, what started out as a tale about a rare interstellar wanderer has taken an odd turn. Astronomers now report that 3I Atlas might be influencing the solar wind in ways never prior to recording. It is doing more than just passing through and being tossed about by the solar wind. It appears to be bending and redirecting the flow, creating a complex interaction zone. The degree of this interaction gives rise to profound questions. What properties must an object have to exert such influence? How does the heliosphere's dynamic environment respond? And what does this mean for our understanding of both interstellar and comet matter? To appreciate the significance of what appears to be happening, one must first consider what the solar wind is and how typical comets behave. The solar wind is a continuous outflow of charged particles, mostly electrons and protons, from the sun's corona, streaming outward through the solar system and carrying with it the sun's magnetic field. It shapes planetary magnetospheres, contributes to auroras, and defines the heliosphere, the bubble of solar influence that envelops the planets. Under normal circumstances, when a comet enters the inner solar system, its nucleus warms and volatile ices sublimate, generating a coma of gas and dust, and typically to tails. A dust tail pushed away from the sun by radiation pressure, and an ion tail shaped and carried away by the solar wind, possessed of a magnetic field embedded and charged particles. In this setting, the comet is largely passive and does not respond to external forces rather than imposing them. This is why what we're seeing with 3I Atlas is so remarkable. Instead of simply being shaped by the solar wind, it appears to be influencing the wind's behavior in its vicinity. Observations have revealed dust emission on the sun-facing side of the object and tail features not strictly aligned with the classic antisolar direction. Particularly, there is evidence of a sun-facing plume or emission and reports that dust is being ejected sunward, opposite to the usual comet tail orientation. That, in itself, is weird. What makes it even richer is the suggestion of bending or deflection of the solar wind around this entity, hinting at some combination of magnetic interaction, outgassed material, and a previously unobserved mode of comet solar wind interaction. Imagine a boat traveling through water. Usually, the water flows past the boat and the boat leaves a wake behind. But if the boat has thrusters that push the water aside or generate vortices, then the flow around it changes, perhaps curling, diverting, or creating eddies. What is being suggested for 3I Atlas is something analogous in the solar wind. The comet is not only passing through the wind, but its own properties may be altering the local wind flow, causing deviations from the expected streamlines of plasma and magnetic field lines. What could be producing such an effect? Several candidate hypotheses are currently under discussion. The 3I Atlas 1 possibility carries a strong magnetic field or has acquired an induced magnetic environment due to its motion through the wind. If the object is coated in conductors or has a charged dust layer, it might set up a magnetic perturbation, which in turn could influence the flow of plasma in the area. Another possibility is that the outgassing from the object is much stronger and more precisely directed than usual, injecting neutral or charged atoms that ionize and join the solar wind flow, creating a local obstacle or shock. The interplay of dust, gas, charge, and magnetic fields may combine to create a bow-shock or magnetosphere-like structure around the comet, altering the wind's trajectory. Also intriguing is the object's age and origin. Atlas 3 appears to have been traveling through the galaxy for billions of years. Its hyperbolic path suggests it originated in another stellar system, was ejected long ago, and entered our solar system at very high velocity. Estimates suggest its age could be anywhere from 3 to 14 billion years, making it possibly older than our Sun. In such a time frame, it would have been exposed to cosmic rays, interstellar dust, and radiation in ways that solar system comets are not.